Hi everyone, thank you for being here. Today I'm here to talk about graceful labeling of graphs. The graceful labeling was defined in 1967 by Alexander Rosa. A graph G of size M is graceful if there exists an injection F from the vertices of the graph to the set from 0 to M, such that every possible difference of the vertex labels of all the edges is the set of the numbers 1 to M. Here is an example of the path on 5 vertices. This path has size 4, and here's the labels of the vertices. And the labels on the edges are the numbers in the set 1, 2, 3, and 4. Rosa introduced the graceful labeling as well as a number of labelings, as well as a number of other labelings as a tool for decomposing the complete graph into isomorphic subgraphs. In particular, the graceful labeling originated as means of attacking the conjecture of Ringel. That conjecture says that the complete graph on 2m plus 1 vertices can be decomposed into 2m plus 1 subgraphs that are all isomorphic to a given tree with n edges. Here's an example. We have the complete graph on 9 vertices. You can find 9 disjoint subgraphs isomorphic to this tree. In 2021, Montgomery et al. Proved Ringel's conjecture for every sufficiently large n, and an unpublished result of Erdos say that most graphs are not graceful. So we are interested in finding large families of graceful graphs. So here first I'm going to give you a definition. A shell is a plane cycle with chords where all the chords share a vertex. A shell whose inner faces have all the same size k will be called a k shell. In this table, you can see all the known families of graceful cycle with chords. For example, the shells which have only faces of size 3, the shells with 1 chord, the shells with 2 chords having an inner face of size 3, also shells with 2 chords but having an inner face of size 4, and shell with 3 chords having 2 inner faces of size 3. So we prove the following theorem that say that let n greater than or equal to 5, a shell with base cycle of size n having the minimum number, the maximum number of consecutive 4 faces is graceful. So here's I'm going to show you only the how to obtain the labeling. But it's not hard to prove that it is a graceful one. So we start with a shell Sn with base cycles Cn. We can notice that Sn has at most 1 inner face of size 3. And to be precise, if n is odd, then Sn has exactly 1 tree face. And if n is even, all of its faces have size 4. The first case is when n is equal to 2k plus 3. We have that the shell Sn has k chords and size 3k plus 3. So we start labeling the edges. We will label the edges starting with this one with numbers with consecutive numbers in descending order, starting with the greater one. In this case is 12. We start with 12, 11, 10, 9, 8, 7, and so on. Then we label this vertex with 0, and we sum the label of this edge in order to obtain the label of the next vertex. In this case is 0 plus 12 is 12. Then we rest the label of this edge to the label of this vertex in order to obtain the label of the next vertex. Then 12 minus 11, we obtain 1. And we made this for the rest of the vertices. So we obtain that the course of the cycles in size in the vertex with the label 0, and in size also in the vertices with the labels from 1 to k. In this case is 1, 2, and 3. And we obtain all the numbers in the set 1, 2, 3 until 12. The next case is when n is equal to 2k plus 4. Also, we have k cores, and in this case, the size of the shell is 3k plus 4. Here is how to obtain the labeling. It's a little different from the previous one, but we obtain the labels of the vertices in the same way as the previous case. We are interested in these graceful graphs, in particular plane cycle with curves, because there exists a relation between graceful graphs and conservative graphs. Conservative is also a labeling of a graph. Here's the definition. A graph G is conservative if it admits an orientation and a labeling of the edges with the numbers from 1, 2 until the size of the graph, such that at each vertex of degree greater than 2, the sum of the labels on the incoming edges is equal to the sum of the labels on the outgoing ones. For example, in this vertex, the sum of the labels on the incoming edges is 8, and on the outgoing one is 8. So we can see that on the rest of the vertices, we have the same property. Bench proved that if a plane graph is graceful, then its dual is conservative. And as a corollary, we proved that if a plane cycle with curves is graceful, then its semi-dual is conservative. So here's what I mean with dual and semi-dual. The dual of a plane graph is a graph which we obtain by for every face of the plane graph, we put a vertex, including the exterior face, and two vertices of this new graph are adjacent if the corresponding faces shares an edge. And we obtain the semi-dual, taking the dual and split the vertex of the exterior face as many times as the degree of this vertex. And here's the semi-dual. I'm not going to delve into this because of the time. It, it has a lot of details, but I want to show you that graceful labeling of a plane cycle with curves induce an conservative labeling of its semi-dual. In this case is a tree. So you can see or realize that these labels, this is a graceful one and this is a conservative one. So that's all I want to say. Here are the references, and thank you.